Hi everyone. Okay, so for today we are given a titration problem, and our question is a 75 milliliter solution of hydrochloric acid with an unknown concentration is titrated to the equivalence point with 27.3 milliliters of 0.157 molarity of calcium hydroxide. Now our question is, what was the original concentration of HCl in the original solution? Now, I've already drawn out the picture to go along with our balanced stoichiometry equation. Now what we have is we know that we have 75 milliliters, which right here is going to be 75. Now, this is a common mistake for these kind of problems, is that for our equation, we are going to need to look for liters, but what we're given is milliliters. So we divide our units, and we're going to get to 0.075 liters. And right over here, we have calcium hydroxide, which is going to be a molarity of 0.0157 molarity, which is given right here, and our converted milliliters into 0.0273 liters of calcium hydroxide. Now for each mole for calcium hydroxide, we are given 1 calcium to 2 hydroxides. And over here with hydrochloric acid, we have 1 H for every chloride. Now, for these kind of problems, we're looking for the next molarity for molarity of 1, but we're given the molarity of 2 and the volume of 2. Now, these are not the same types of molecules, so we're not allowed to do M1V1 equals M2V2. Both of these are common mistakes that we have to look out for. Now, with our mistakes over here, what we want to do is we are switching these over to liters. So we know not to use these. But we're going to be using these in liters and not milliliters. Now, we move on to what do we know? So what we know with our problem right here is that HCl has the molarity of unknown and a volume of 0.075 liters. And calcium hydroxide has the molarity of 0.157 molarity and a volume of 0.0273. Both of these are liters. Now what we want to find is to get to the moles of hydrochloric acid is we're going to find the moles of calcium hydroxide, which will give us the moles of hydrochloric acid, which we can then use to find the moles of hydrochloric acid, the molarity of hydrochloric acid. Now, to find the moles of calcium hydroxide, we can use the equation that molarity is equal to moles over liters. Now, whenever we rearrange this equation, we can find that moles of calcium hydroxide is going to equal to molarity times liter, which is then we're going to move on to how to calculate. So right here, what we're given is our volume is going to be 0.0273 liters of calcium hydroxide times 0.157 molarity. This right here is going to give us moles of calcium hydroxide. And to find the moles of hydrochloric acid, we're going to do a mole ratio. So according to up here, we have 1 mole of calcium hydroxide for every 2 moles of hydrochloric acid. And this is due to the balanced stoichiometry. Now, whenever we plug this into our calculator, we are given 0.00858 moles of hydrochloric acid. Now, we've gotten to this step right here, and what we need to do is find molarity. Now, molarity is equal to moles over liters. The question we're asked in the question above is the concentration of hydrochloric acid in the original solution. So what we were given was we have moles, so 0.00858 moles of hydrochloric acid over the liters that we were given, 0.0075 liters. Make sure it's not in milliliters, so we want to avoid the common mistake. And the final answer that we're given is going to be 0.114 molarity of hydrochloric acid. And that's going to be our concentration for hydrochloric acid in the original solution. Thanks for watching.